Good afternoon, boys and girls, and all the teachers that are watching. My name is Ngaka, and today we are going to work together to have a look at what we have in chemistry, the organic chemistry. And then our focus, we will be looking at the nomenclature, how do we name and draw the organic compounds. And then later, we've got 4 sessions. Later, we'll do the physical properties and see what is it that the properties, what we have learned in grade 11 about the intermolecular forces, the impact that it has on the boiling point, the melting point, and the vapor pressure. So today we are going to start off by looking at the whole of organic chemistry and see how the names are, how we name these compounds according to the number of carbons that we have. And then towards the end of the lesson today, I'll show you the homework that I'm going to give you that we are going to do the correction of when we meet again next week. All right, so we can start. I'm going to mostly use the PowerPoint presentation that you are looking at, and the first thing that is appearing there is organic chemistry. This is the chemistry of carbon compounds. We'll be looking at the whole carbons and what is the structures that are made up of, and some uses of the structures later. All right, so why is it so important to talk about organic chemistry? If you look at the processes that are happening on Earth, most of them are based on organic chemistry. You can think of the car that you are using to travel to school. It uses petrol, and petrol is one of the compounds that we have in organic chemistry. And then it's also useful for the products that we have, like the plastics that we are using to carry our grocery from the shops, the drugs that we are using when we are not well. We are not talking about the drugs that people are buying, the Mentrax and that. We are talking about the medicine. The drugs we are referring here to is the medicine. So all those are made from the organic chemistry. And then the petrochemical, this is the petrol, the diesel that we are using to drive our cars, the explosive that we are using to extract minerals from the ground, the paint. These are the ones that we are using to make our houses look beautiful, and so on. So there are so many products that we are using that are made from organic chemistry. And then here are some terminologies that I want you to have a look at. And then if you struggle a bit about these terminologies, we can have a look at the exam guide that your teacher should have given to you on page 15 of the exam guide. Let me just switch over to this so that I can take you through this. On page 15, this is where you've got your organic molecule, and these are all the molecules that you'll be looking at. Alkanes, alkynes, and then later we'll be looking at the haloalkane, the alcohol, the carboxylic acid, the esters, the aldehydes, and the ketones. And when we look at this, we will not be focusing on the cyclic. So the cyclic are not part of your syllabus. And then the terminologies that you must know, the molecular formula, the structural formula, the condensed formula, the hydrocarbon, the saturated, unsaturated compounds. So these are the things that you must know. So if you want the correct definition for all of these terminologies that we are talking about, have a look at the exam guide. Don't look at the definition from the textbook, because sometimes it is explained in the way that the examiner is not requiring. So you must have a look at the exam guide at how the terminologies are explained. All right. So let us continue. So the homologous series, we say here these are the compounds with the same functional group and the same general formula. And then the functional group, the bonds, the atoms or group of atoms that determines the chemical and the physical properties of an organic compound. And then the general formula can be used to determine the molecular formula of a compound in a homologous series. And then the homologous series, we are talking about the alkane, alkene, alkyne, and haloalkane. And then on the side there, we've got the functional group. How do you identify that this compound belongs to the alkane, this one belongs to the alkene, this one belongs to the alkyne? So if you look at this one here, where you've got a, let me just take out my pointer so that I can show you what I'm talking about. Change the ink. Okay, right, it's fine. If you've got a single bond between two carbons, then you know that this compound belongs to the alkane. If there are double bonds between two compounds, two carbons, you know that this one is the alkene. And then the triple bonds between two carbons, that one is the alkyne. And then the haloalkane will be the carbon with the X, where this X stands for any of the halogens. Here we are talking about fluorine, chlorine, bromine, iodine. So those are your halogens that when we combine with the alkanes, we refer to them as haloalkane. And then the other ones that we have are the alcohols, the aldehydes, the ketones, carboxylic acid, and the esters. So this is what I want you to do before we go any further. It is important to know the name of these compounds and how we name them. So this is what I want you to do. Take out your book and the pen, and I want you to draw for me this table here. It should look like the one that I'm drawing here. All right, and then let's say here you've got number of carbons, and then the second column there, let's call it prefix. We are doing a little bit of English here. And then this one will break it like that and call it suffix, where we will break it into those. So this is what I want you to draw in your book, because I'm going to teach you the names here depending on the number of carbons, so that later when we get into the details of naming these compounds, this table will become very useful to you when you look at the homologous series or the functional group in which where you are looking at whether this is a single bond between carbons or double bond or triple bond, and then just look at the number of carbons and the name will just come up automatically. So this one we'll call it alk, and then let me change the pen here and call it alkane. And then the next one, alkene. And the last one, alkyne. All right. So these are the three homologous series that we refer to them as hydrocarbons, where you've got only the hydrogen and the carbon in a compound and nothing else of another atom. All right. And then when you are done drawing this table, let me just give you a few seconds to draw the table so that I don't leave you behind. Okay, I believe you are where I am now. We'll call this 1, 2, 3, 4, 5, 6, 7, and the last one, 8. So what you have to know is, with the name of these organic compounds, is the one that contains 1 carbon up to 8 carbons in your long chain. So the prefix for 1 carbon, we'll call it meth, and then this one is eth. 3 carbons is prop. 4 carbon is but. 5 carbons is pent, like pentagon. 6 carbon is hex, like hexagon. 7 carbon is hept, and then the 8 carbon is oct, like October.